So we just got done looking at this example where we rejected the null hypothesis that told us that at least one of the means, or here the mean weight losses, of our three groups is different. So we would like to know, well, not only that there is a difference, but which ones are different and how they are different. So we're going to talk about how we are going to do that in this video. So what we're going to be doing is what's called a multiple comparison test. If we reject the null hypothesis, we would like to know which means are different and how. Now we're only going to be worried about this if we reject the null hypothesis, because if we didn't, there is no evidence that they're different. So there's no reason to look for differences. So only if we reject the null hypothesis will we do this multiple comparison test. So in our example, we did reject the null hypothesis. So what this means is we would like to be able to compare the average weight loss of dieting to the average weight loss for those that exercised. I would like to be able to compare the mean weight loss when you do nothing to the mean weight loss when you diet. And I would like to compare the mean weight loss of doing nothing to the mean weight loss for the exercise group. Right? So really there's three comparisons here that I would like to do. So we really don't want to have to do a ton of extra work. So the good news is there is some options that we can do here in StatCrunch that will allow it. So we will actually show you how to do our original stuff in StatCrunch, as well as show you how to do this extra option. So this extra option in StatCrunch is called the Tukey HSD with confidence level, and you have to fill in that confidence level. The confidence level that we are going to want to give it is whatever 1 minus alpha is. So for example, in our previous example, we had a significance level of 0.05. So with this alpha of 0.05, that would correspond then to having a 95% confidence interval. What this is going to do for us is it actually will create a confidence interval of the difference for all pairs of the population. So imagine what it's doing is it's doing a confidence interval for two independent samples, like it did in the previous module. So it's going to do a difference in two means for diet and exercise, a difference in two means for nothing and dieting, and a difference in two means for nothing and exercising. So it's going to automatically create a confidence interval for each of those. So the question then remains is once I have those confidence intervals, how will I know if they are different or not? Well, what it's going to come down to is looking for the key number. If you remember, the key number in our previous module was 0. So 0 is going to be our key number. If the confidence interval contains 0, what that means for us is a 0 is a possibility for the difference. So what that means is that it actually contains 0. Between these two groups, there will be no significant difference. Well, what then that means for us is if then the confidence interval does not contain 0, that means there will be a significant difference. And for those that have a significant difference, we'll be able to figure out which one is bigger and by how much. What we will be looking for is then we'll use the order of subtraction and the sign that is, if it's positive or negative, to determine the direction. And by direction, we just mean which one is bigger. Now, since we're going to be getting a whole bunch of confidence intervals, what it will look like if the confidence interval contains 0 is that you're going to get a negative number to a positive number. Versus if the confidence interval does not contain 0, what means we're going to get a negative number to another negative number, or we'll have a positive number to another positive number. So that's the explanation of what we're going to be looking for. To keep it separate, I'm going to do a separate video where we actually do this for our example.